slide, or do you want me to continue with the next one? Yes,
I think
boys?
redo.
Redo. Okay, fine. So, what is sound? We are describing sound by the factors as frequency, amplitude, and speed, right? These are the features of sound wave.
Okay, ma'am.
And boys, wherever you find that you're not able to grasp whatever I'm saying, you can don't allow me to continue then, please. This is a humble request to all of you. Is it clear? Is it clear? Boys, can you hear me?
Yes, ma'am.
Yes, ma'am.
Now we can show the sound as wave, right? This is what how like this. Got it? We can show this sound as a wave. Sometime whenever the sound is obviously it is using a medium. If there's no medium, we cannot hear sound, we know that. So whenever the sound is moving in a medium, what we have seen? Compression and rarefaction, isn't it? What does the compression means? That means the density is high. What is rarefaction? That means density is low. You agree? Boys, do you agree?
Yes, ma'am.
Yes. So I'm trying to make use of certain terminologies so that you understand it very well. So what does density, thickness and thinness? Is it clear? So compression, thickness. Rarefaction, it's apart, thinness. Is it clear now? So density is maximum in compression. Density is minimum in rarefaction. All of you agree? All of you
Yes,
agree?
ma'am.
Okay. So what I said just now has been repeated over here. See, compression's regions of high pressure and density. You agree now? What is the compression? High pressure and density. Very close to each other. What do you say? Isn't it? So particles are very close to each other. And where do you see all this compression? In the form of crest. Now, what is crest? I think I've told you already. This, this upper portion is called as crest. So you get the maximum density over crest. Is it clear? Any problem, beta? Hello.
No.
Rarefactions are the regions of low pressure. Particles are spread out. Got it? Particles are spread out. And it is shown by the lower portion, which is known as trough. Let's see the graph. Now here we see that upper portion you can see this is crest, lower portion is trough. Can you see this? This is the middle line. Can you see the middle line better? Here, this is the middle line. So the upper portion is crest and the lower portion is trough. This much you should understand. Now, what is wavelength? Wavelength is two consecutive. Now, this is one, this is the second one, this is the third one, and this is the fourth one. So, if I say consecutive, this is a mathematical terminology that means one after the other. Successive. Consecutive is sort of successive. So, this is the first compression and this is the second compression. So, distance between two compression is known as wavelength or distance between two consecutive troughs. Now, these are troughs. Let's take a bottom one. These are troughs. Can you see this? These are troughs. Got it now? So distance between these two or these two, this is also lambda. Got it now? Have you understood better? It's either the distance between crest or the distance between troughs, this is equal to wavelength and it is denoted by lambda. Any problem?
No.
Are you really understanding? And this is a not a ordinary word, but it is a Greek letter. And the unit is meter. What is the unit, beta? Meter. Hope you have understood. Now look over here. This is how the wave travels. Can you see over here? So wherever you can see, these are the condensation, the dark patches. Can you see this dark patches, beta? These are condensation. Now this condensation is called as compression. What it is called as compression. And when you see, you know, this portion, these are rarefaction. Hope you have understood now. The pockets that I'm making, these are rarefaction. The dark patches are condensation and the white patches are rarefaction. Hope you have understood this much. Hello. Hello, boys.
Yes, ma'am.
Any problem?
No, ma'am.
Start reading fast so that we can explain as many slides as possible. Please start reading.
Sound does not travel in vacuum. Sound is a material medium like solid, liquid, or gas to travel and be heard. Therefore, sound waves are called mechanical waves.
Any problem regarding these three lines?
No, ma'am.
We already know all these things. The sound needs medium. It cannot travel in space. Yes, we did an activity, remember. Hence, these are called as mechanical waves because it needs a medium. Any problem, beta? Now we'll see what are the characteristics of sound wave. Please start.
Characteristic of a sound wave. Amplitude. The maximum distance moved by a vibrating air layer on either side of its original position is known as the amplitude of the sound waves. Its SI unit is m.
Meter. M is
Meter.
meter. Then
Wavelength. A distance between two successive compression or two successive rarefaction is called wavelength. Its SI unit is meter. Time period. The time taken by an air layer to complete one vibration to and fro motion is known as the time period of the sound wave. Its SI unit is second. Frequency. The number of complete back and forth vibration of an air layer in 1 second is known as the frequency of the sound waves. Its SI unit is hertz. Relation between frequency and time period n is equal to 1 upon time.
T, time period. What is that, beta? Time period. Fine.
Period.
So what is amplitude? Now, this is the mean. I've shown you this is the wave, sound wave, right? The maximum distance from the mean, this is amplitude. Got it now? The maximum distance from the mean, all these are amplitude. Any problem, beta? I've shown you right now. What is it, beta? Say at least something. What is it? The maximum distance from the mean
Amplitude.
amplitude. So it is, this one is crest and this one is trough. Wherever it can be. It can be in crest, it can be in trough, no problem. It is the maximum distance. That is amplitude. What is the unit? Meter. Any problem, beta? Any problem?
No.
Now, we just saw distance between two consecutive crests and the distance between two consecutive trough is lambda. Any problem? This is the distance. Any problem, beta?
No.
Just now we read. Okay. Now time period. Now in 1 second, for example, this is the pendulum, right? If 1 second, the pendulum is moving to and fro. To is this one and fro is this one, isn't it? It's like a swing. So in 1 second, how many oscillations it takes place? How many oscillation, how many vibration? So one vibration, how much time does it take? That is called as time period. And what is that one vibration? It goes here and it goes back. How much time does it take? That becomes time period. Hope you have understood. What is one oscillation, beta? To and fro motion. How much time does it take? For back and forth motion, for to and fro motion, that becomes time period of that particular object. Okay? Now, what is frequency? Frequency is how many oscillations it is taking in 1 second. How many times it is going back and forth, count. That becomes the frequency. You understood? And the unit is hertz. And if we club the frequency and time period and get one equation, a formula, then the formula between frequency and time period is n. N could be written as nu also. Remember, I have taught you nu is equal to 1 upon t. So frequency is inverse of time period. This is how you have to remember. You have to just mug it a bit. Okay, you have to learn all this thing by heart. Any problem, Peter?
No.
Any problem? Okay.
No.
Here, this is a wave. You can see there are two types of waves. Can you see two types of waves, Peter? This is the first one and this is the second one, right? What does it suggest? The wavelength is short. Here the wavelength is long. Agree? Better be fast. If I'm asking a question, I need an answer.
Yes.
Yes. So that is short wavelength. This is long wavelength. Now, short wavelength means you just count how many wavelengths are there. 1, 2, 3, 4, 5, 6, 7, right? Here, in this case, this was just 1, 2, and 3. Do you understand? Now, what does it suggest? The short wavelength means lots of waves. Agree? There's so many waves. Agree or not? That means
Yes.
the frequency is high. Number of waves which are forming is high. Frequency is high. And the sound will be also high. You understand? It should be loud sound. In case of long wave, that means the waves are few. The waves are few. Frequency is low. So obviously sound will be feeble. That is sound will be also low. Any problem? I hope you understood the difference between the short wavelength sound and the long wavelength sound. Is there
Yes.
any problem? Okay.
No.
Now the frequency of sound, how do we understand what exactly is the frequency sound? It is pitch. Is it's so loud that you have to close your ears. That is high pitch. You understand? Whisper. If someone is whispering to your ears, it is low pitch. Hope I made you understand. Like if there's a screeching of a chair or a table, you close your ears, isn't it? That is means it is high pitch. You understand now, Vita? It's unbearable to hear. It hurts your ears, isn't it? That is high pitch. Got it? So this is how we talk about a frequency. We relate it with the pitch. As is it a high note or is it a low note? So highness or lowness of a sound measures the frequency. See over here. Low, agree, and this is high. This is in between. This is in between. Okay. Now low frequency means low pitch and the wavelength is long. High frequency means high pitch, wavelength is short. Can you see this? Now what about this one? This is pleasant to hear. What do you say? This is pleasant to hear. It is neither high nor low. It is audible. Is it clear? Is it
Yes.
clear? Now, frequency we have understood is due to the shrillness of sound. Now, what is time period of sound wave? Please, one of you start reading it.
Time period of sound waves, the time taken for the change in the density of the medium from a maximum value to a minimum value and again to the maximum value is the time period of the sound wave, or the time taken for one complete oscillation in the density of the medium is called the time period of the sound wave.
Read.
It is represented by the letter T. The SI unit is second as frequency and time are represented as follow. For one oscillation, time period is equal to 1 upon V or V is equal to 1 upon T.
B. It is new. Remember, I taught you. It is new.
Yes, ma'am.
Forgot, beta? See. N, U, and this is how it is to be written. Yes or no? Remember? Hello? Didn't I teach you this earlier? It is denoted as like this, but it is pronounced as new, N-U. Got it? Boys?
Yes.
Okay, fine. So this is a relation of the frequency and time period. Just now we are revising it again. It is nu is equal to 1 upon t or t is equal to 1 upon nu. What exactly is the time period? It is one complete oscillation. How much time you are taking? Not you, sorry. How much time the particle takes to oscillate? That is to and fro motion. How much, if this is the particle, how much time it takes to come here and then come here? That is one oscillation. So the time taken by this, by doing or by oscillating is called as time period. It is letter T, unit is second, and the relation between the frequency and time period is it is inversely proportional to each other. If I put T on the left hand side, then it is 1 upon nu, and if I put nu on the other side, then it becomes 1 upon T. Any problem, beta? It's just revision we are doing. We have all done it. Hello? Boys?
Yes, ma'am.
Have you understood
Yes,
what I'm
ma'am.
saying?
Yeah, ma'am.
Now you can see if I say high frequency waves, can you see the number of waves is more over here and number of waves is less over here. Yes or no?
Yes, ma'am.
Hello? Got it? The time is same, but how many oscillations is taking? Can you see this? It is more and then the time is same. See, this is time. Can you see it over here? Hello. So higher frequency, the sound will be high. Low frequency, the sound will be low. Simple. Got it?
Yes, ma'am.
Okay. Now this is period. Can you see this time period? What we call it is lambda or the wavelength. That is time period. So the time period over here is small and the time period over here is big. What do you say? That means the time taken in high frequency wave is less as compared to low frequency wave. Have you understood or not, beta? Have you understood or not? See, look at the period over here. See, got it? And look over here. Which is more? The time period is more in low frequency wave. The time period is less in more frequency wave. Whereas time period is more in low frequency. You understand?
Yes.
Now we come to amplitude. It's all revision, remember that. We have done it, it's just a revision we are doing. Read better.
Amplitude of sound waves, the magnitude of the maximum disturbance in the medium on either side of the mean value is the amplitude of the sound wave, or the amplitude of sound wave is the height of the crest or thought.
Rough.
It is thought. It is
Rough.
represented by the letter A. The SI unit is the same as that of density or pressure.
So we already know what is amplitude. This is the maximum distance. Okay? Where from the mean value to the crest or the mean value to the trough. How it is denoted? By letter A. Let's see over here. So what is this is the wave. Distance between two crests or the distance between two trough, it is wavelength. Yes or no? Hello. Please respond. The distance between two crests or two trough is wavelength. Boys, can you hear me?
Yes, ma'am.
Do you agree whatever I'm saying or not? Or if you really want to say something else, you can. Like what I'm saying, you don't have to keep on saying yes, yes to me. If you have your own views, if you are not able to follow, you can stop me. All of you are following or not? Boys, do you follow or not?
Yes.
Yes, ma'am.
This you agree that it is wavelength between two consecutive crest. This is crest, remember? These are trough, all these are crest, and the bottom ones are trough. So if I take all these length or the distance, that is wavelength. Either it is crest or I take it in the trough. All these are wavelength. What do you say? It is denoted by lambda. This much you agree with me? Hello?
Yes.
Yes.
Now what is amplitude? Amplitude is this one. You take the maximum length from the mean. This is amplitude. Now, I can take it here also, anywhere. This is the maximum length from the mean, which is known as amplitude. Any problem?
No, ma'am.
This is amplitude. And this is wavelength. This is wavelength. You got it? This is wavelength, this one, and this is amplitude. It is measured in Armstrong. That we'll do it later. So wavelength depends upon how high the crest is. See, the wavelength is the distance between the crest of two waves or the troughs of two waves, which are consecutive or next to each other. What is amplitude better? It is how high the crest is or how high the. If the crest is this much, then the amplitude will be this much. Yes? If the wave is this much, then the amplitude will be this much. What do you say? Hello? Boys, do you get me?
Yes, ma'am.
It all depends upon how high the wave is. If the wave is very high, the amplitude is big. If the wave is small, the amplitude will be small. See, this is small wave, amplitude is small, and here the amplitude is so big, isn't it? It depends on the height of the wave. You got it? How high the crest is. So all these are crest, remember. This is crest. Okay? This is just a revision of compression and rarefaction. We had, remember, we had taken slinky, the spring, and you compress it and you try to pull it. This is how it looks. See, here it is highly entangled. Here also it is, see, very close to each other. These positions are known as compression, and when they are apart from each other, these are the portions which are known as rarefactions. So compression means the closeness or the close part of the wave, and rarefaction means the spread out of the wave. Amplitude is again the maximum distance the particles in a wave vibrate from their mean position, that is called as amplitude. And what it controls? It controls the volume and the intensity of sound, how loud it is. More the amplitude, louder will be the sound. Less the amplitude, feeble will be the sound. It will be weak. Okay, beta? So, this amplitude depends on what? It depends upon the closeness of the waves. More close the waves, okay? If it's very close, it will be high pitched. For example, this is spring A. Can you see this? This one? This is spring A and this is spring B. Now spring A has got amplitude more than spring B. Can you see this over here? And can you see this over here? Have you understood? So the closeness is very, see, you can see the closeness is too much over here, where it is getting apart. So the amplitude over here in spring A is larger than spring B. Hope you are understanding. More close, more amplitude. More apart, less amplitude. This is what they wanted to show you. Any problem, beta? Hello?
No, ma'am.
What is pitch and loudness of sound? Please read, beta. Please read, beta. What happened?
Pitch and loudness of sound. The pitch of sound, shrillness or fatness, depend on the frequency of vibration. If the frequency is high, the sound has high pitch, and if the frequency is low, the sound has low pitch. The waves are all traveling at about the same speed. So this is the number each wave that will reach
Please,
the
ear, ear,
ear
ear
ear in a hundred
of a second.
of a sound second.
Second, second. And short wavelength means lots of waves, high frequency, high sound. Okay? And long wavelength means fewer waves, low frequency, low. This is, we have done it already. This is just the part of revision. We have done this, remember? I showed you the types of waves, remember? Just now. This one, right? We had done this already. So this is a means of revising the same thing again and again. So what is pitch, by the way? How flat or how it's like if someone screams, that is shrillness. If someone talks, that is flatness. This much, have you got the difference of the pitch better? Find it different? This is called as pitch. Now, what it is depending on? It is depending on the frequency. What is the relation? If frequency is high, the sound will be, it's like whistle. If you whistle, that is high pitch. But if you talk, that is a low pitch. Did you understand?
Yes.
Yes? Okay. Now, waves generally travel same speed. So, how many waves will reach your ear in that particular time? You can make out over here. This is your ear. See, you can see this is your ear, right? And the waves are traveling and reaching your ear. These are the short wavelengths. That means so many waves are traveling, so many waves are coming with high frequency and high speed. Now this is called as high pitch. That means this is shrill. What is this, beta? Shrill. Low wavelength means fewer waves and is flat. This one is flat. Hope you understood better?
Yes.
Yes? This is the difference, the number of waves. Sounds are traveling, we know that the same speed. One wave we saw is having the shorter wavelength. Yes, the shorter wavelength wave will go more frequently. So what it has? It has a higher frequency or high pitch. That means the sound will be higher. Hope you have understood. What are we talking about? This one. This is moving fast, isn't it? Because it's got a shorter wavelength. So many waves are reaching my ear at the same speed. So obviously the sound will be high. It will be high sound. Because it has got a short wavelength. And here it will be low sound. Is it clear?
Yes, ma'am.
Same way. It is a low pitch sound, that is low sound. Because wavelength are very big. These are all wavelength. Very big. Look over here. Here it is high because wavelength is small. It's clear now?
Yes.
Read better.
The loudness of sound depends upon the amplitude of vibration. If the amplitude is bigger, the sound is loud, and if the amplitude is smaller, the sound is soft.
This also we know better.
Yes,
This also we know. It's fine. So what is amplitude, by the way? This is the amplitude, isn't it? This one. Is that the amplitude? What do you say? The distance between the mean and the crest or the trough. Yes or no?
yes,
Yes.
Yes? Okay. And if I take this one, The amplitude is only this much. What do you say? Yes or no? So this is louder sound because the amplitude is bigger. This is softer sound because the amplitude is smaller. Any problem?
No.
So if I get a loud sound, if I say, okay, beta, what is the amplitude? You will say it is more. Amplitude is large. So the sound is high. You got it now?
Yes.
So what is the amplitude is loudness? Simple. More amplitude, louder will be the sound. So it is a directly related. The loudness relates amplitude. More the amplitude, louder will be the sound. Got it now? So it is a size of wave. Now see amplitude. Small amplitude beta. Can you see this? Boys. So it is a soft sound. What sound it is? Soft sound. Low intensity. Now look over here. It is high. Can you see this big one? Yes or no? It is louder sound. High intensity. Got the difference? Boys, you got the difference between the louder sound and the softer sound? When
Yes.
you
Yes.
come on amplitude? Yes? Now just club both of them. Can you see this? I'm clubbing both of them. This is low intensity because the amplitude is small. This is high intensity because amplitude is big. Can you see this difference, beta? Just compare. Understood all of you?
Yes.
Yes, ma'am.
Okay. Now we'll come to speed of sound. Please begin.
Speed of sound. The speed of sound is different in different media. The speed of sound is more in solid, less in liquid, and least in gases. The speed of sound also depends on the temperature of the medium. If the temperature of the medium is more, the speed of sound is more.
What is the relationship between speed, frequency, and wavelength? So what is it, beta? Let's see this
Speed
relation.
of
Speed is
sound
equal to
is at 25 Celsius. Relation between speed v, frequency v, and wavelength.
frequency is
Speed is
nu,
equal.
beta.
Yes,
Speed
new,
is v, frequency is nu.
new. Speed is equal
Wavelength
to
is
wavelength into frequency. V is equal to nu into V.
that is nu into beta. Speed is v,
Yes.
wavelength is
And
lambda,
Prepul is very
frequency is
that.
nu, beta.
Yeah.
You again and
Nu
again.
into
Frequency is nu.
V.
Yes. Speed is v, wavelength is lambda, frequency is nu. You understand? Don't get confused. It's written over here, doesn't matter, but what how we are reading. That is nu. Frequency is always nu. So you will pronounce it that way. Is it clear?
Yes.
Okay. So what is the speed is equal to wavelength into frequency. So speed is v, wavelength is lambda, and frequency is
Name
nu.
की
So
नवीन
this
है
is the relation between the speed, wavelength,
तो वहाँ
and
से हटेगी
frequency. Is it clear?
Yes, ma'am.
Yes.
Yes. Okay. So what this is the relation you got. We know that speed is different in different media. What we found that in solid is the maximum, followed by liquids, and the minimum we get in gases. Hello, someone's mic is on, I think so. And what it shows that when the temperature, please put up the mic. Hello? So if the temperature is more, then speed is also more. Yes, beta, can we?
Speed of sound. The rate of which sound travels in a given medium is called speed of sound. The speed of sound depends on the nature of material or medium through which it travels. In general, sound travels slowest in gases, faster in liquid, and fastest in solid. Speed of sound in air is 344 meters per second at room temperature 20 Celsius. Speed of sound in water is 1500 meters per second. Speed of sound in iron is 5130 meters per second.